This is how embeddings actually work. An embedding is what happens when the machine takes something human-readable, like a sentence, a document, an image, or a product description, and turns it into a list of numbers, a vector, which sounds sterile, because it is. But that vector is doing something important. It is placing the thing inside a mathematical space where distance means similarity. That is the center of it. Season 1 version, an embedding turns meaning into location. Season 2 version, an embedding model takes input, processes it through a neural network, and outputs a numerical vector that captures useful features for comparison. Still cold. Now with plumbing. Let's say you write, affordable used SUV with all-wheel drive. A keyword system looks for words, affordable, used, SUV, all-wheel drive, very literal, very obedient, very likely to miss the point if someone phrases the same idea differently. But an embedding system tries to capture the meaning behind the phrase, so a search for cheap pre-owned crossover for winter driving may land near it, different words, similar intent. That is why embeddings matter. They let machines compare meaning without requiring exact wording. Now, how does that actually happen? First, the input is tokenized, because as always, language must be chopped into pieces before the machine can tolerate it. Those tokens become numerical representations. Then they pass through an embedding model. That model has been trained so that similar inputs produce similar vectors. A vector is just a list of numbers, could be hundreds, could be thousands. Each number is not usually something clean, like number 47 equals sadness, number 193 equals pickup truck, number 812 equals divorce energy. Unfortunately, reality is not that considerate. The meaning is distributed across the whole vector. Patterns spread through many dimensions. The model does not put dog in one number and friendly in another like a spreadsheet made for toddlers. It creates a dense numerical representation where the overall position captures features of the input. That position can then be compared to other positions. The most common comparison is called cosine similarity, which sounds like a skincare product for mathematicians, but it is simple enough. It measures whether two vectors point in a similar direction. If two embeddings point in similar directions, the system treats them as semantically related, not identical, related. That distinction matters. Embeddings are not magic truth detectors. They do not prove two things are the same. They say, these things appear close in the model's learned representation space, useful, not sacred. This is how semantic search works. You embed a bunch of documents, store their vectors in a vector database. Then when a user asks a question, you embed the question too. Now the system can search for document vectors near the question vector. Not because the same words appear, because the meanings are nearby according to the embedding model. That is the machinery behind a lot of modern AI retrieval. Search, recommendations, clustering, deduplication, memory, RAG. Matching questions to answers, finding similar products, finding related scenes in a video archive. All of it depends on turning messy content into comparable coordinates, but embeddings have limits. They compress, and compression loses things. A short embedding may miss nuance. A bad embedding model may group things poorly. A query may retrieve something similar but not actually relevant. Two pieces of text can be close in meaning but wrong for the task. Because similarity is not the same as usefulness, this is where ranking, filtering, metadata, hybrid search, and human judgment come crawling back into the room. Embeddings are powerful, but they are not the whole system. They are the map coordinates. You still need to decide which roads matter. So how do embeddings actually work? An embedding model converts input into a numerical vector. Similar inputs are trained to produce vectors that sit near each other in a high-dimensional space. Those vectors can then be compared using distance or similarity measures to power search, retrieval, recommendations, clustering, and memory. It is not understanding in the human sense. It is mathematical proximity. A machine saying, these things are near each other in the geometry of meaning, which is not a soul, but it is enough to make a search engine look like it finally learned how humans fail to say what they mean.